Okay, so this is my UART breadboard. I've not had this out for a little while, apart from to use it to interface my CPU to my PC. So this has basic send and receive functionality, but the big drawback on this is if it's receiving a string of bytes, if the CPU doesn't read it back out quick enough before the next byte is received, it's gone. That's why I built this circuit. This is a 4-byte Fifo buffer. So if I fire some bytes at it, they're received, displayed on these LEDs, and then this line driver can conditionally stick it back onto the main bus as and when the CPU is attempting to read data. The Fifo buffer, if it was connected up, would take the byte of data as it was received, stick it into one of the 4 bytes it's got here, and only feed it out on demand. Now what I want is for a Fifo buffer with 8 bytes on both the transmit and the receive. So on the receive it will let us grab bytes out if they've come in a little burst and we didn't get them as they arrived. And on the send buffer it will make it a lot easier for us to actually saturate the outgoing connection and have the bytes go one after another without needing careful timing on the CPU. So this would need to be this circuit plus one other breadboard for the other 4 bytes doubled. So we can kind of see that the combined UART would end up being pretty big at that point. So what I want to do is convert the buffer in a slightly more advanced form into a PCB that I can use as a small module on the breadboards to implement the send and receive Fifo for the UART. So let's do some PCB design. So we're going to need headers for data in and data out. We've got control lines for read, write, output, enable and reset. But we're going to need power and ground. So we've got read address, write address, and count 0, 1, 2, 3. Bingo. And we're definitely going to need power and ground as well. Okay, well I think that's the schematic finished off. So we've got headers for all the input and output lines. I've added the caps, we've got some display LEDs. Let's see what we can do about routing that. The worst thing is these data lines, you could switch the input and the output and it wouldn't matter at all. So the numbering is completely arbitrary as long as they are the same on both the input and the output. I can't be bothered to turn them all around. Do I want some LEDs on these control lines? I've noticed this PCB is almost square. I just need to save one 2.54mm square off here to give it a square profile. Okay, those bus connections are the majority of what we have to do. Though I suspect a lot of the complexity is going to come from here. Now this arrangement should match this one, so maybe I can route it and then copy it over. You know, I think I'm going to make my life a bit easier by switching this to a 4-layer board. In fact, let's compare the cost. It's going to cost me $4, $8. I don't see why I shouldn't do that. Going 4-layer really does feel like cheat mode. Not many lines left to go. So these are actually just the 4 outputs that specify the number of bytes inside the buffer. Now, do I want read and write LEDs? I think maybe I do. Now these are active low connections, so we want to be orientating the LEDs away from VCC. Now that is a long way between where it comes in, where it's used, and then where the LED is going to be is all the way over there. Slightly roundabout route, but it's only driving an LED. Okay, it definitely seems to be weird problems with the design rule checks on these 4-layer PCBs. And they were all supposed to be grounds. Okay, I think I've got them all. Now that is a beautiful PCB. Okay, so this arrived at the same time as one of the ALU PCBs. Very keen to see this. Okay, now this is a pretty simple circuit, so I'm hoping I've not made any mistakes on this. Let's get some components out and try and solder it. Okay, that paste went on incredibly easy compared to the previous solder paste I was using. What I'm going to do though is remove the solder paste off these pads because I wasn't planning on using that today. So these are the up-down counters. One of them is incremented when we receive a byte, or in-queue a byte into the Fifo, and the other one is incremented when we read a byte out of it. .283 is an adder. It's used to subtract the number of bytes taken from the number of bytes added, which gives us the total. We need these inverters to turn an add into a subtract by means of 2's complement arithmetic. Then these 138 demultiplexers allow us to take those current index values and address the latch chips that hold the data. Now, I definitely dropped one there, but I haven't got a clue where it went. Okay, just the latch chips now. Okay, so I'm mildly paranoid. I want to recheck the chips in the right place. Okay, let's get this stuff out of the way and get ready for soldering. Okay, this solder paste doesn't seem to pull stuff into place quite as well as the old stuff. I hope it's making good connections. Bunch of pads like this where it seems to have formed a little ball rather than spread out on the pad. Let's hope that's just normal behaviour. People screaming at me that I almost missed the power there. Okay, let's see if we can work out a way to test this without needing to completely rebuild the UART. So here's the UART, and I've got a couple of these BB830 breadboards, and I'm hoping we're going to have less trouble with these than the cheaper ones I've been using. I bought these for starting on the display circuit, but I can borrow them for this for a little while because I'm not expecting it to last for very long. So the module's dropped in okay. Let's actually line VCC and ground up with where we can use it. What are we going to have to do to get some functionality out of this? Okay, so we've got a reset line here, be active low, so let's bring it high. We've got an output enable, we're going to test it, so I'm going to bring that low. Okay, so we've got a data read line and a data write line. Okay, so this isn't debounced, so I don't know quite what I'm expecting there. Okay, so here's my little line test circuit. Let's plug the power for that in. Lost the switch off there, but we don't really need it right now. Okay, so that right counter is working a bit nicer. It does seem to be double counting a bit. Is it me, or does it look like that counting has the two bits here the wrong way around? Okay, so the zeros go to the zeros, ones to ones. Ah, look at that. Oh, what a terrible mistake to make. So both my 193s are outputting the wrong bits. That's a nightmare. So I've just got two lines that are inverted. Now, is there something I can do about that? Is a bodge possible? Okay, so if I wire these straight across here and cut the tracks underneath, that might work. That one's going to be tougher though. Okay, now what's curious though is this should actually be partially functional anyway, even though it's not accessing the chips in the right order. They're both swapped in the same way. Right, so I should be able to pick up the data from here. Feed that into data in. Get some LEDs set up. Okay, those ones are quite dim. It's a little bit better. Now I am going to have to do a new PCB because I think that's a pretty nightmare bodge to do, and I want to use 2 of these modules on the final build, and I don't want 2 lots of bodges. But that should be taking the data that's been received and putting it on the inputs, and that should be the signal that a byte has been received. Okay, so in theory I've received byte now, so I've connected basically the receive signal that would normally just be latching the data into here to the load signal of a in-queue read signal on the Fifo. Now we know we've got some bits swapped around, so that's showing a 2 instead of a 1, but the data's turned up there. In theory, if I go on and send additional bytes, so I've done the ASCII values for the numbers 1 through 5 there. This is still showing the first byte that we received. Yeah, that's worked. The data output size that basically outputs a 4-bit number for the number of bytes in the buffer is not giving the correct data. Now a lot of the time it looks like these 2 bits have been swapped around, but since it's the values going into the add operation, I think there's going to be some weirdness to it. Right, so let's fix this. Everything else seemed to be working okay. That's such a trivial change. Better luck this second time then. Okay, that was just, I needed to force it to rebuild the internal planes there. Okay, so the mistake on these counter chips is slightly annoying because I really should have spotted that, kicking myself for it. But it's quite a simple fix on the PCB. And so I'm just going to get an order off for a couple more of these. And it won't really interrupt me too much because we'll just jump straight into integrating for the received, and replacing this one with the fixed board should simply mean the display is correct. I could actually go on and just use this board as is, because the only thing we're going to do is get the incorrect count out of here. And of course, the only thing we're really interested in on the receive side is whether or not there are 0 bytes available. But let's get this PCB replacement ordered. Okay, well, I hope you found this interesting. Thanks a lot for watching, and hopefully I'll see you again soon. Goodbye.